Here we go. Go ahead. All right. This is when there's a little twist in that quantity. If the quantity that's inside those parentheses isn't factored, then we have to factor it, okay? Always factor. What's the first thing you factor out? Always. The GCF. All right, so always factor out the GCF, but sometimes it's difficult to figure out what to do. So we're going to look at that. But then we're going to set that quantity in the center of the compound inequality. Using 0 as the beginning point. No different than what we've been doing. And the period as the ending point. It helps us determine those intervals. Okay? Wow. So that's what we're going to do. All right, so what are we going to do? When the period isn't 1, how are we going to handle that? Okay? So if you look at this problem, wow. We've got to factor out a GCF, and we need to make that coefficient 1. So the way we're going to do that is we're going to factor out a GCF of 2. Whatever that number is, that's what we want to factor out. Now look what's going to happen. We're going to rewrite this cosine 2 times the quantity. This is the weird part because of the fraction at the end. It's going to be x plus, when I take out a 2, what's that going to leave with this 2 pi over 3? It's going to leave pi over 3. Now that one's easy, but sometimes they're jacked up and you're like, what? Okay, that one's not difficult at all. Now we can go about finding this, graphing this, and we should be fine to go through all of that stuff. Is this going to reflect? Yes or no? No. What's the amplitude, and where do I find it? In front of the cosine, it's a 1, so the amplitude is the absolute value of 1. Period. The period is always 2 pi over what? Usually, it's the number directly in front of the x. Well, folks, now it's 2. We factored out a 2, so we're going to take 2 pi over 2, which is pi. And now we need to find our intervals, which is 1/4 times pi, which is pi over 4. That'll help us. Does this have a phase shift? Just going right into order of the function. This is going to move. It's plus pi over 3, so that means it's going to be left pi over 3 units. And then is there a vertical shift? How do you know? There's nothing added or subtracted at the very end of the function. Now, it's cosine, so where's the oscillation line? Excuse me, sorry, I sneezed. Oh. Oscillation line at the x-axis. All right, now we could graph it. Let's graph it real quickly. Let's take our quantity before I put anything, and it's going to be 0 is less than or equal to x plus pi over 3 less than or equal to who? Pi. Good. And then we're going to subtract pi over 3. What's this allowing us? What's this helping us do? This is going to help us find our second, third, and fifth point, right? Then it's going to move to the left, pi over 3, which is what we had anticipated already. And it's going to run from negative pi over 3 to, what's pi minus pi over 3? What's 3/3 minus 1/3? 2 pi over 3, right? All right, now. What we started with? Oh, I don't know. I don't know. And I'm never going to tell you it's always going to end up being what you start with. I'm never going to tell you that because just as sure as I do, there'll be an exception to the rule, and it's not going to be the case. So I don't know. I don't care. I keep doing the same thing over and over again. So it doesn't matter to me. All right, so I'm going to take my beginning point plus my interval, and it's going to give me my next point. Right on? All right, beginning point. What's our beginning point? Negative pi over 3. It's already there. Plus my interval is pi over 4. This is weird, okay? Folks, this is when all you have to do is take your calculator. This should be a no-brainer with your calculator, okay? Pardon me? Oh, it's okay. Sorry. All right. All right, so here we go. There's no reason for us to tax our brains. We got negative 1/3 plus 1/4. Please make sure you use parentheses. Oh, decimal, math frac. All right, so it's negative 1/12. So negative pi over 12. Y'all with me? That goes to the next spot. And I'm going to add the same interval every time. Calculator. All right, negative pi over 12 plus 1/4. Yuck, math frac. 1/6. Pi over 6. Is everybody with me? Yes? Is that a yes? Is that a yes? Star heart, is that a yes? Is that a pouting because I don't want to do this? That's a pouting because I don't want to do this. Plus 1 divided by 4. If it's any consolation, neither do I. But we got to do it anyway. Because we just have to suck it up and work. 5 pi over 12. 5 pi over 12 plus pi over 4 has got to get us to 2 pi over 3. Holy moly. Pi over 4. 1 over 4. Come on. Yep. Good. 0.6 repeating is 2 pi over 3. All right. All that work. Now we're able to graph it. Y'all ready? No? Are you going to be ready? Okay, why not? All right, so here we go. So we have our graph, and this is going to move to the left, right? Correct? There it is. What was our amplitude? 1? All right, good. So that's just easy. And it's going to move, our beginning point was pi over 3. And then it goes to negative pi over 12. Because this is our first point, this is our second point, third, fourth, end. Right? All right. So, negative pi over 3 is going to be somewhere over here. Here's my suggestion. Whatever you do, just keep your units, your intervals, the same width from each other. I don't care where this thing ends up, negative pi over 12. just as long as I keep the same width when I get to pi over 6. And then 5 pi over 12. And then 2 pi over 3. Will these curves go through the origin? No, not necessarily. We talked about that on Friday. So this is, I don't even know what curve this is. Is this sine or cosine? Cosine. Is this an up cup, down cup? Up cup. This is our normal cosine curve. So that means it's going to start here at 1, up here at 1. This is where you have to be real careful. And it's going to come up here to 1 as well, if it's an up cup. So it's going to come down through this. It's going to come down to 1 at pi over 6. So I got to make it kind of flat there. And then up through. Do you see how each of the intervals have a specific job? Not job, but the curve kind of turns on each of those 5 increments. Do you guys see that? Questions at all? Yes? That the oscillate. What did I not do? Y'all did, but I always do that and I didn't. Is that what you're asking? Okay, I don't understand what you're asking.
The middle of the interval.
Okay.
It goes through negative 5 over 12 and through 5 pi over 12. Like kind of how it goes straight.
I don't know. I think they're answering your question back there. You got an answer for this? You're being rude. You didn't hear what she asked, did you? The cosine curve is always going to have to go through the second. Not necessarily. Not necessarily. No. We'll work on one. Okay. All right, here's another one. Look at this one. 3 sine of x. Sine of the quantity 2x minus pi over 2. This is when, to me, it's weird. Because when I factor out my 2, because it's what's on top, this is the weird part, I think. All right, now, I've got to factor out that 2, right? When I do that, I've got to make sure that I multiply this number by my coefficient over itself. Now, what am I actually multiplying that little angle by? 1. But I have to put it into a format where I can pull out a 2. All right, and I have to see it. You may be able to do this in your head, and if you can, wonderful. But I'm going to rewrite this as 3 sine 2x minus 2 pi over 4. All right, whatever that coefficient of that x is, I'm going to take that number and I'm going to multiply it, that number over itself, to my angle pi over 2 or pi over 3 or 2, whatever that angle is, okay? Now I can physically take out a 2 for my GCF. And when I do that, that's going to leave me with x minus, if I take out 2, what's that going to leave me with? Pi over 4. Okay? Because remember, I'm factoring out 2 over 1. Okay? So when I take a 1 out from the bottom, it stays the same. All right? Now, here we go. Do we need to go through the same stuff again? Do we need to go through the amplitude, the period, any of that stuff again? Let's do it. Here we go. Is this thing going to reflect? Hey, do this one yourself. Do you need me to talk you through it? Try it yourself. Does it reflect, yes or no? Amplitude. Absolute value of 3, which is 3, period. 2 pi over 2, which is pi. What is the period? Describe the period. No, that's not what I asked. Describe what it is. What is it? What's this mean? Can't say. Say it again. It is 2 pi divided by whatever that number is, but what is the period of the function of the curve?
The units? Is that the units?
Say it again. Say it loud so everybody can hear you. It's however, if we relate it back to the unit circle, it's however far we are rotating that angle around that unit circle. We are looking at it the literal length of the curve, okay? If you relate it back to the unit circle, it's however far that angle is rotating around the origin, I guess, around that unit circle, okay? Very good. That's what I was asking. Period. Phase shift. Moving to the right, pi over 4, and then vertical shift. Does this have a vertical shift? No. So that means my oscillation line is the x-axis, right on. All right, when we figure this out, pardon? I forgot interval. What's 1/4 of pi? Pi over 4. All right, so that's going to give me x minus pi over 4. Hey, is this going to end up being nice? All right, so looks like it's going to be. So it's going to start at pi over 4, and it's going to run to 4, 5 pi over 4. All right, so we got, if it starts at pi over 4 and our intervals are 1/4 pi over 4, then won't we just take steps to get to 5? So that our first one will be 1/4, 2/4, which is actually pi over 2, 3/4, 4/4, which is plain old pi, and then 5 pi over 4. Yes? All right, sometimes you don't have to go through all the work. 1 pi. Is that what you're asking here? You got to have the pi in it, yes. So, graphing it should be fairly simple. And let's see, we went to the right, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. Oscillation line is the x-axis, and its sine amplitude is 3. Folks, you need to be sure that you label your axes, and it's going to start on the x-axis or not? Yes. And is it going to rotate going upwards or downwards first? It's going to go up because there is no reflection. So it's going to go, this was your question. So my top point is going to be here, and it's going to curve and go through the middle point. My bottom point will be here. And I just put them there as guides for me because I want my curve to look the way it's supposed to. How many of you had that on your paper before I just did this problem? Good. Folks, you got to be able to do this.
So the only one that doesn't look either on it or above it is the one right in the middle, and that's because the line goes through the middle?
Yes, for the sine curve. Okay. All right. Now, look at the next one. Last one. What's the GCF? All right, we want to take this number out. It's always the number right in front of the angle. This angle happens to be theta, not x. That's okay. So if I put 4 here, then what am I going to multiply to pi over 2? 4 over 4. because I don't want to change its value. I just want to change the way it looks. So that's going to be 4 theta plus 4 pi over 8. What are we going to factor out? 4. So it's going to leave theta plus pi over 8. That's all. All I'm doing is taking the 4 out of the numerator, leaving everything else alone. Yes, ma'am. Yes. Yeah. It doesn't matter. It's just the name of the angle. Okay? I want you to see a theta in your problem because you may in a quiz or a test or exam, whatever. Okay? Yep. Whatever number's right there in front of the angle. That's all I'm doing. And a lot of you are going to be able to do this in your head. And you're going to go straight from this right here, and you're going to go, oh, well, I'm going to just throw that, make that an 8. And you're going to go straight to this step right here. I can't do that. I need to see the step. And in my teaching, I need to show you that step. If you choose to go from here to here, I'm okay with that. But if you make a careless mistake, I can't give you partial credit. Okay? Now, hey, go through this one yourself. You don't need me to guide you through it. Find everything, graph it. I think that's it. 3/8. How many of you have all of your amplitude, period, phase shift, vertical shift, blah, 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 blah? Good. Okay. All right. Pardon? Yeah, I'm still figuring. You can put just left or right. That's fine. I'm just putting that because I know where I'm going to start at pi over 8. Okay? Yeah, that's fine. Hey, where does that take me? It takes me to 0. And then it takes me from 0 to pi over 8. Oh, this is going to be easy. Are you seeing the pattern already? All right, so it's going to take me negative pi over 8, 0, pi over 8. 2 pi over 8 is going to be pi over 4. That's a 4. And then 3 pi over 8, right? Oh, that looks bad. But here we go. What was the amplitude? 1. All right, that's good. And I'm going to the left, pi over 8. Ah, and this one goes through 0. Is that right, or is this a fluke? It's right. It just happens to go through that value. What's going to happen? Is anything going to happen when I throw a vertical shift in there? Is that going to throw you? No, because all you're doing is now it's based upon your oscillation line, right? All right, so what curve was this, sine or cosine? I don't remember. Sine, so it's going to start where? At negative pi over 8, it's going to actually start on the x-axis. Is this going to reflect? I don't remember. No reflection. So it's going to go up, and then it's going to go through pi over 8, and it's going to go down here. Its minimum value is at pi over 4, and then back up. How many of you had that? Rock on. Questions? Yes.
When you do have a vertical shift,
Uh-huh.
I know when we're labeling it, we're labeling the x-axis,
Yes.
but is it still on the x-axis because it's
Well, you're labeling the intervals on the x-axis because those are our x values, okay? But if it had a vertical shift of 2, and it's up here and your oscillations line is up here, you still have to put your intervals down here on the axis. And you have to label the x-axis and the y-axis. Don't leave anything blank. Pardon? No. I mean, I don't care if you do this or this, but you do not leave this y-axis blank without numbers. Don't just graph the oscillation line and think, oh, there it is. No, it's not. Do it. If you're going to do it right. Okay? Yes.
okay? That's right. Like, what is the first number like?
Have we done a problem? Yes, because we had, I think it was a sine curve or maybe, I don't know, one of the two, and we had to move up a half. So yes, sometimes that could, and it looks weird because it's only like this big. When we graph it, it looks like this. Like, it's weird. Because we are usually used to seeing it tall, okay? Any other questions? Hey, you got one problem. One problem. And I think it's going to be considered classwork, okay? Nope, you're not turning it in. But you better be ready to graph one problem tomorrow, two problems. One normal, okay, and one where you got to factor out a GCF. And you know where I'm going with that problem. What's it going to have in there? Oh, well, it might have theta in there, but no, that's not. It may have a vertical shift. So don't sweat this, okay? It's a piece of cake. But we're done with this graphing. It's page 1. I think it's page 143. Page 143, number 25. You may put this in your notes. Nope. No more tests. If you have anything, you will have quizzes. You will not have any tests. Unless you have to take the exam, and that's when you're going to have your test. Oh, you'll get a review just like you do for every other test you've taken. Pretty tough.